All right, welcome everybody to week 16, day 3. We've got 1 week of school left, and then after that it's finals week, and there's no finals in this class, so cool. I think we're basically doing Zybooks, so there's kind of nothing else to talk about. There's graphs, I guess. I might put that up just to keep you guys from being bored, but we'll do that after Huffman coding is in. I want you guys to focus on Huffman coding. Wow, look at that. Okay. So, recursion. All right. Where is Putty? There we go. Okay, so Java Rainfall is pretty easy, pretty straightforward, I think. Inside of the Java folder, there is some sample code for you, and it kind of explains the basics of programming, right? So I guess you can just go through it. It's actually probably pretty useful for you. So instead of cout, so I kind of translated between C++ and Java for you guys. Like I said, if you learn C++, learning Java is pretty straightforward. It's not immediate, but it's pretty straightforward. So instead of cout, use system.out.println, or print if you don't in the new line. To do input, input's a little weird in Java. So you have to create a class called a scanner, and you make a variable of type java-util scanner, and you pass in system.in. System.in is the equivalent of cin. And then you tell it what type you want to read. It's basically kind of like how my read library works. So my read library can say, give me the next integer. Yeah. I will return the next integer in the input stream. I think I have an example of it down here. So I make a variable here called cin, just for old time's sake. And again, you have to new everything, right? Every variable in Java is the product of a new operation, except for primitives. Okay. So I'm making here a scanner variable. And the reason why I didn't have to do java.util.scanner is because I have imported it directly. So if you import java.util.scanner, then you could just use scanner. It's like the using directives in C++. You don't have to fully qualify everything, which gets kind of tedious. So I make a new scanner and I initialize it with system.in. System.in is the keyboard, all right, console. Okay. And then I'm going to cout. Please enter how many hello worlds you want. I make an array of 100 arrays. Again, you can't just be like int array square bracket 100. No. Everything in Java is nude except for primitives, right? So that's the thing that everyone forgets, right? Like, people will go like int are like this, and yeah, don't do that. New everything. So you can set element 10 to be 42, element 100, this is going to go out of bounds, right? So we can comment that out. And this, even though it's square brackets, Java does bounds checking even on square brackets. And so Java is a safe language. It's designed that way. That's why a lot of financial services companies will use it when they don't need the speed of C++. Has no delete. How does it not annihilate memory? Yeah. The language itself, or the runtime, I guess is the better way of putting it, will detect when something is not accessible anymore. So when this guy goes out of scope, there will be no way of getting at this chunk of memory, and so it will deallocate it. So it tracks who can see which chunks of memory. Every so often, Java will pause, do garbage collection, and free up all the memory that isn't accessible anymore. So you can't really lose memory in Java unless you really work at it. You could you can allocate things in main that just don't go away, right? You can do that if you want to. Yeah. It hurts the performance for the sake of garbage collection. Yeah, if you've ever played Minecraft, you know what a pain that is. And people will sit there and play with all the different parameters for garbage collection, how often it runs, and things like this, trying to create a smooth experience. It's one of the reasons why Java is extremely unpopular in the games world. Right? Because you need to have a smooth, regular frame rate, and the garbage collector interrupts that. So this is how you do a read from CN, basically. So what this is going to do is read from the standard input, and it's going to give you the next integer the user types in. This is equivalent to int x equals read, like that. Right. Very similar. Okay. Except the read library, you don't have to specify it's an int, because it can deduce that from the left-hand side there. Nice. Okay, so who was a student that said, I hope someday to be proud of something as Kearney is of his read library. Yeah, I like it. Gonna admit that. All right. So, what? Yoxtimer. Yeah. If you want to read a float, then you do something like this. Float f equals cn.nextFloat. You don't have to call it cn, by the way. That's more of a joke than anything else. But that's, this is the idea, is that you've got some scanner object, and you say, give me an int, give me a float, and it reads out of the keyboard and returns the value that you're looking for. Okay. So, this code should make sense to you guys, right? If x is less than 0, right? Else, if x is less than 10. For loop, for int I equals 0, I is less than xi plus plus. Else, right? All of this is completely understandable to humans. Right? To C++ people. This is all, yeah, it's all the same. Instead of cout, we do system.out.print, or we can import that if we wanted. So you can print without a new line, you can print with a new line, or you can call print line, and the print line will do the new line for you. If x is less than 10, then x times we will print hello world to the screen. Otherwise, it is going to, I don't know what this is doing. It's going to print out 2 times x minus 3. So it takes x, multiplies it by 2, subtracts 3, calls integer toString on it, and that converts it to a string, and then it prints that out. So, yeah, everything in Java is in a class, so there is no toString function like there is in C++, which is a global. Instead, everything is found within a class somewhere. If you want to do hypot is a function in Java, just like it is in C++. So if you want to see what the distance is on a 3, 4, 5 triangle, it'll be 5. And so this will convert the number 5 to a string, and it will print it. And notice here we've got the plus. So this is going to append 2 strings to each other. So we're going to have a first string, hypot 3, 4, and then that will be appended to double quote 5. Is this all pretty easy to understand for you guys? Like, compared to Huffman coding, it should be pretty easy. Yes, if you want to use my read.h, you have to download it onto your machine if you're going to use it on your home computer. And so if you're just going to put into your local directory, do hashtag include double quote read.h instead of angle brackets. Angle brackets means it's installed in the system. Include directory. Double quotes means it's in your local directory. Or if you want, you can specify a full path name if you feel like it. But if you want to use it, just download it from GitHub, put it into your local directory, hashtag include double quote read.h. Work fine. Okay. Can you use your read.h for any of your future products? Sure, it's on GitHub. Yeah, absolutely. When you become a professor someday, you can give it to your students as well. It still probably won't be standardized by then. Okay, so yeah, variables are pretty much the same. They do have the capital I integer, capital F float kind of stuff for doing class operations like toString and stuff like that. Algebra is exactly the same. Addition, subtraction, multiplication, division, modulus, all the same. If else, else if, blah, 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 all that's the same. You can't use the words and and or. That's unfortunate. You have to use double ampersand and double vertical slash. So they, I don't know why. I think the lookup and is better. But, yeah. You gotta use the old C world way of doing it. Loops are the same. Range based for loops are the same. While loops are the same. Do while loops are the same. They're all the same. It's all the same. Everything's the same. Functions. If you want to make a function, you would have to do. Oh no. So I guess HiPot isn't standard, right? So I made a HiPot function here, and you can see I called it down here just by calling HiPot, right? And so it looks like it's a global function. This looks like what you do in C++. You call HiPot, hypotenuse function. It's not about getting high on pot. It's the hypotenuse, right? So I made it a static, so it's not attached to any variables. So you don't call like a dot HiPot. You just call HiPot. And if you're within the class, it's just HiPot. It functions like a global function, a free function. So we've got here a function called HiPot, takes in two doubles, returns a double, and it does the square root of x squared plus y squared. I wish I was high on hypotenuse. Okay. Yeah, there's my GitHub. It has my colors.h and my input, or the read library in it. And is more readable, I think, but I don't know. I got into a disagreement with somebody online who's like, I don't see anyone ever using and, so you shouldn't use and because nobody uses it. I'm like, well, with that attitude, nobody will, right? Like, not my fault that people you know are all stuck in the 80s. You know, time changes, man. Okay, so here we've got a function called Bob. Bob takes in two doubles. You can see here we're making a string, and again, we're using new, right? The plus operator is the only overloaded operator in Java, and so you can overload the plus operator for strings. Oh, not like you can. It is overloaded, and nothing else is. So normally plus only works on your primitive arithmetic types. But in Java, they did specially overload it for the string class. It's the only class that actually has a plus operator for it, or any operator for that matter. So it will then append IAM_foo to itself. So it becomes IAM_foo, prints it to the screen. If A is greater than B, I don't know what we're doing here. It's just whatever. Just demo code. If A is greater than B, return 2 times A. Otherwise, return the absolute value of 2 times B. You guys see how this is like if I made that like a quiz question, let's say, and I said, is this C++ or Java? What would you guys say? Is this code valid C++ or Java? The answer is yes. Because it's an or. It's true for at least one of them. I didn't say XOR. No. Yeah, it's both valid. This highlighted code is both valid Java and it's valid C++. And you'll see that a lot. You'll see that a lot. The core language is the same, right? It's a standard library that's the main difference. And you got some minor differences like this or whatever, but with that Java, this thing that I've given you here, like it has examples of everything, and that's enough to really be able to do Java, honestly. All right, so let's go through some of the other issues. Yeah, if, else, if, all of them are the same. You just can't use and or. Little gotcha there. Loops are all exactly the same. Functions are basically the same. If you want to use sine, cosine, etc. in the standard library for Java, it is called java.lang.math. So you can see up here, I have imported all of them. And I've imported them so that I can just use those symbols directly, right? So I can just say sine of 0, cosine of, pi or whatever. So you saw down there I was just using abs, And so by importing it, all those symbols come in. All those functions come in, and I can use them. So in C++, this would be called CMath, right? Because C++ has never made its own version of the C math library. So we still use the C library because it works fine, I guess. I don't honestly have any real complaints about it, except I do wish C++ would add a multi-precision class, a multi-precision integer, so that you can have infinite precision integers. Like, that's something I wish, C++ would add. Because that'd be really nice. Because right now, C++ is limited to 64-bit integers, and that's just not enough, honestly. It's honestly just not enough. So, that's like a big thing that I want the standard library to add, is multi-precision integers. For, at least when it comes to this chunk of the world. What are these to count pi? It's a double. It's a 64-bit float. And so again, having a multi-precision library would allow you to have 128 bits of pi, 256 bits of pi, 512, 1024 bits of pi. That would be actually kind of useful if you're doing a lot of very high performance, or high precision rather, not high performance. If you're doing very high precision ray tracing and things like that, or if you're trying to send people to Mars, you want to have as many digits of precision as you can, and limiting it to 64 bits of precision. If you're trying to figure out what angle to go to, and you're talking about a circle whose radius is the orbit of Mars, every digit of precision works out to like a pretty big chunk of space, right? So, okay, yeah. So, yeah, I mean, basically, same kind of stuff's in there, just in a slightly different place, right? Java Lang math. Arrays, if you want to make an array, you knew it, right? So I was talking about earlier, everybody forgets you just get into the habit of just knowing everything when you're in Java. And then you just access arrays like you do in C++. If you want to do a vector, then this is kind of the recommended way of doing it. You make a list, and you were like, oh, is this a linked list? Well, no, there's a list superclass. And when you do this, new array list int, then what happens is this is a subclass of list, and it's inheritance, right? And so what happens is that it's like what we did with the hash table. So this list class is a superclass, and you can actually say, do I want it to be a linked list or a vector? And in this case, I want it to be a vector. Okay? And so this is making a vector of integers, basically. And you can call pushback on the vector, except it's not called pushback. It's called add. Okay. So if you call add, it pushes back 5 in this case. It'll push back, push back, push back. You should probably use this for the Rainfall Assignment. If you want to get the size of it, I believe it's still dot size, I'd be surprised if it wasn't. So for your Rainfall Assignment, you are just going to read rainfall numbers and add them to the vector. And then after the input phase is over, you're going to average the results, right? So average the rainfalls, average the rainfalls on rainy days. There is one twist to the Rainfall Assignment. Now, the Rainfall Assignment, by the way, is a classic computer science assignment. It's actually one of the things we use in the literature to compare the performance of students at different institutions. It's a well-known homework problem, suitable for first semester computer science people, because you have to do a little bit of this and a little bit of that. You have to do error checking, right? So what if the rainfall for the day is reported as negative 100, right? What if you got negative inches of rainfall, right? It's not possible. So you have to discard those values. So you have to do a little bit of error checking so that if these are types in negative 100, you don't process it at all. It doesn't get counted as one of the days of rain. It doesn't count as a sunny day. You just discard it. It's bad sensor reading. Happens. Okay? And so you have to maintain a data structure. So you put the inches of rainfall into a vector like this. And then you can do a range-based for loop over the vector for every integer colon vec. Sum plus equals that integer, right? Add up all the things very easily. Same as C++. So if you guys know how to add up everything in a vector in C++, you should be able to do it here. .at is called .get. So this will get element 10 out of the vector. Or you can use, like I said, a range-based for loop will work as well. So you can say for int x colon vec. Exactly the same thing, as far as I remember. There's no gotchas there. Classes, basically the same. One really beautiful, awesome thing about Java is you don't actually need that semicolon at the end of the class declaration. So that's nice. I like that. You don't need no semicolon down there. Rather than public and private sections, each member is tagged as public or private. It's public, private, protected, same as C++, and no modifier, which makes it public within the package you're in. All classes in the package can see it, but private outside. Do they know why they make you type new for everything? Yeah. So I think you need to be explicit when you're allocating memory, right? I guess they could probably make it so you just use it automatically. Yeah. It's a good objection. Okay. So if you want to do file I/O, like an IF stream kind of thing, then in Java it's just called file, capital F file, and otherwise it works pretty much. You pass in the file name and double quotes. It's really very, very similar to how C++ works, and that's not a coincidence. Java was designed to be very easy to port from C++ to Java, and I've done it. Like, I worked professionally porting code from C++ to Java, and it wasn't hard. Like I said, just a lot of Googling sometimes. Like, how do I get the time? You know? Right? Like, how do you get the current... how do you get the number of seconds since January 1st, 1970 in Java? Right? You know, this was my life for 2 years. You know? How to get the current date and time in Java. And then you get to read documentation, you know, or you can consult. Somebody asked last time, do you always just have to Google it, or is there official documentation? Yeah, there's official documentation. Did I use it? Yeah, sure, absolutely. A lot of times, like, if you want to dig more into, like, what is this date time formatter thing? Like, it's got some sample code here, you know. But, like, if you want to dig into it and be like, all right, what options are available? You know, then I consult the documentation. Most of the time, though, like, if I want to just, you know, that seems promising. You know, all right, date is equal to Java util date. Print the date. Okay, where is clock? Where is clock? Did I see that? There we go. All right. So system.out.println, java.time.clock.systemutc.instant. There you go. Okay. So there. It's current time. Okay. Or in UTC time. Or you can get the current time in your time zone. Okay. So Java time, local time now, right? So there's a lot of options for getting dates and times in Java. And so I just, all you really do as an experienced computer science person is you just see somebody who's done that job already. And
This is in fish prison now.
Okay. Being too aggressive?
I put a divider in.
Gotcha. Okay.
If you still have offense, I'm tossing her to the cycler.
Gotcha. All right. My wife is angry at a fish. So there you go. Okay. Yeah. And like, I guess some students are, I don't know, don't like that, but I mean, it's the life of a professional programmer, just like nobody's got all this stuff memorized. I mean, if you do this on a daily basis, sure, but like your brain is like a cache. Your brain caches the most recently used and the most often used things, right? I could spit out a for loop without needing to look it up. You know what I mean? But like, how do I get UTC time? It's like I just look it up. There's no shame in that. And learning how to do that yourself makes you an independent programmer. That's actually a big part of like growing up as a programmer, is you no longer need your professor to explain everything to you. It's like, you can start figuring stuff out on your own and seeing sample source code and grabbing it and using it and stuff like that. A big part of computer science is, seeing examples and adapting it to your needs. And there you go. That's how most programs go. Try and put all the leak code solutions in my cache. Do you allocate the amount of time to write the code, or do you add a lead to assign you a time? Is it 25% of the jobs is translating code? I don't know. Like for me, like, no, I don't think so. I don't think that translating code is that common, but I got a lot of jobs like that, and I think it's just coincidence, honestly. And maybe after you've done it for a while, it's like, if they ask you, hey, have you ever ported code before? And I'm like, have I? And they're like, you're hired. And so, maybe it becomes like a self-fulfilling prophecy, but I would port code from C++ to C and C++ to Java, and, between C++ from one platform to another, and all the system calls change. And so you have to go through the documentation and be like, all right, how does this system call work on Linux? How does it work on this other variant of Unix? The parameters are different, and you have to really be able to grab documentation, look at it, and be like, okay, so that thing here would be this thing here. But what parameters should I pick? So sometimes you actually had to kind of think it, and sometimes you'd run the thing on a new system, and it would compile, but it wouldn't work right, and then that's when it really gets annoying, because you're like, okay, so it compiled, it runs, it just doesn't run right. It's not giving me the right answer. It's simulating this water, and I'm getting zeros for everything. And then you like start going like, okay, why is it all zeros? And you're looking at, okay, doubles and floats and nans, and you're like, what's going on here? And I remember one time it was just because the files for the input were in DOS format, because there's actually different text file formats. You wouldn't think it, but it's true. There were different file formats for DOS and Unix, and so they were in DOS file format, and it was just causing the thing to explode, because DOS adds two new lines, kind of. It adds a carriage return and a line feed at the end of every line, whereas on Linux there's just a new line. And so that you don't even notice it if you're doing CN, right? Because CN discards white space. So if you're CNing everything, it just discards the white space. You don't even notice there's a difference between a DOS file and a Unix file. You can copy them to and from. You'll never notice the difference. But if you're doing a program that is like doing getline or something, or something that reads until there's white space, and there's two white space characters, then everything breaks, and it's just like, oh my gosh, but once you figure it out, it's real easy. There's a utility called DOS to Unix. Do we have it installed on here? Yeah, DOS to Unix, and that converts, and Unix to DOS, and that converts the text file formats, and then everything started working. It's like, okay, cool. But getting to that point was like because everything's just zeros, or maybe the first line of this 2D array has the right data in it, and then maybe the next line is all zeros, and the next one has data in it, and you're just like, what the hell is happening here? What the hell? Like, why is it every other line? You open up the text file, it looks fine, it's the same thing, and it's just like, and so porting can be really, really annoying sometimes. But a lot of times it's not. Like I said, when I ported stuff from C++ to Java, it was like, I don't know, not bad. Just look at the documentation and do it. And I did that as a junior in college, so not too much older than how old you guys are now. Like another year or two of computer science, I guess, under my belt. But I did that, not as a working graduated professional. Like I did that in college. It was a college job that I did. Younger than I am now. Yeah, well, I mean, older in terms of years of computer science experience. Let's put it that way. So, yeah. So, do you allocate the amount of time to write the code, or did you have a lead to assign you a time? Depends on the place where you work. It's an interesting question. So, like, most of the managers I've had were fairly hands-off. And didn't really micromanage my time too much. The annoying thing would be like when they would come in, be like, drop everything you're working on. We have a high priority thing you need to do now. And that was always kind of a little bit annoying because like you're in the flow, you're like knocking out some Huffman coding, and the person's like, forget Huffman coding, we're not doing it. You're like, what? Like, or you come back to it later next week. We need you to do this now, and it's like, okay, so that would happen occasionally. I worked for a lot of people that somehow got money from the military in different ways. Like the electrical engineering department at UCSD. My position was funded through a grant from the Navy, I believe. And it was doing like wireless video conferencing that was jam proof, interference proof. Or interference, I guess nothing's proof, but resistant jamming, so you could lose giant chunks of your data stream and you could still video conference. I didn't write the code for it, I ported it. Right? Like I said, I kept getting these jobs porting code for some reason. And, the military guys would come in to do an inspection, basically. So everybody had to get everything ready, Or when I worked at another defense contractor, an ad roll will be coming out, and so you had to like drop everything. You need to put together a demo. You got 2 days or whatever, and so that would happen occasionally, and it's not the end of the world. Mostly though, like the way that it would work is as a professional programmer, and it's different at bigger companies, but like I typically would be like one of 2 programmers. Right, for the entire project or for the entire company. Sometimes, like I was paired with this Polish guy who was a really good programmer, and it sounds like there's a but coming out of it, but no, he was just a good programmer, and the two of us worked together really well, and so we knew what we had to do, and so we would sort of be like, all right, I'll take this part, you take that part, and we would sketch out how our code's going to call each other's code, and that's why it's really important to have public and private things. So I'm going to put a public interface, and these are the functions you can call, and these are the values that they will return. And so you create a stable interface, then I can work on my code behind it, and he could work on his code on the other side of it. And as long as the interface is stable, then our code would get together and work together really nicely. And mostly it's task-based, to answer your question. I ask because it takes time to look up. Usually you just know what you need to do, right? Like it's like you need to port this code to Java. All right. Well, I've got it in C++, and most of the if statements and for loops and things like that are the same. you take main, you stick it inside a class. You know, it's not automatic, like I said. You take main, stick it inside of a class, change some of the, you know, boilerplate stuff to kind of match up. And then your IDE goes, this line doesn't exist in Java, this doesn't exist in Java, this doesn't exist in Java. You go through it one at a time. All right, how do I get the current time? Google, replace, okay? Comment out the stuff that doesn't work, run it, make sure that it works. Okay, and then you just 5 lines of code, 10 lines of code at a time. Like I just would have a giant chunk of code commented out, and then I'd just move the start of the comment block down 5 lines and work on it, and move it down and work on it, and by the time I got to the end, it was ported to Java. And you know, take like a day or two. You know, it depends on you know, how big the thing is, but it wasn't bad. You know, you just get real comfortable at Googling stuff, looking up documentation. Would you pick computer engineering at UCLA or UCSD, and why? It's a good question. I really like UC San Diego, partly because I'm a graduate of it. The quality of education, I think, is good at UC San Diego. UCLA probably has a better reputation. For some reason, I don't know. I'm not exactly sure why, but it's UCLA. It's a top, you know, whatever school. UCSD is like, I don't know, pretty good also. Like, number 35 in the country. Yeah. Out of all the colleges in the country. Right? And UCLA is 20. So, yeah. Like I said, it's got a better reputation. The downside is that is the location. Okay, so UCLA is no, what? No, that's not correct. The hell is this? Australia? No. That is not UCLA. The hell? Why is that the? Okay. Well, you're gonna go to UCSD? Is that your pick? Find out today, huh? Exciting. Yeah, so the downside to UCLA is that it is in the middle of LA. Right? Like, it's a nice campus. It's a small campus. Like, it really is. It's got grass, though, and stuff like that, but it's like this little isolated island, and it's just surrounded by LA. And there's just traffic. Where is Wilshire? Yeah. And there's just, you know, tons of traffic. Westwood, tons of traffic at all, you know, points. And parking's terrible. And it's just things like that just kind of get you, you know? So, so how big is this? That's 100 meters there. So this is at the 100 meter square. So you can see this is actually a really small school, right? My brother-in-law went there, and he got a really good education, got a good job afterwards. So it's not like I'm really, you know, dumping on it. It's a good college, but it's surrounded by LA, and I personally am not a fan of LA, and so that maybe that's my bias. I don't know. But UCSD, there's also the 100 meter scale here. Starts Genesee over here, and this is all UCSD, and this is all UCSD, and this is all UCSD. That's under construction. I think that building exists now. I think this is all UCSD. This is all UCSD. This is all UCSD. Down to here, then it comes over this way. UCSD, UCSD, UCSD VA Hospital, UCSD, UCSD, student housing. So that, you know, like you can see just how much bigger it is than UCLA, and it's nice. Like there's a lot of where is the computer science building? Right here. So this is the computer science building, and there's a giant stone golem there, and EBU1 is right here, and I don't know. Campus is a lot nicer, in my opinion. And the absolute best thing is the weather, right? Like, weather can't be beat. San Diego's got the best weather in the world, honestly. So here's UCSD's campus, right? Like just big open canyon spaces. My buddies and I went over here to shoot off a potato gun, fired potatoes across the canyon. That parking lot is now gone. This is an old photo. They've been ripping out parking lots and putting more classrooms on it. It's really annoying. EBU1. This. If you're a computer engineer, this is where you would take a lot of your classes. And the computer science building's tucked back over right there. This is the computer science building. EBU2. So this is like where you're going to spend most of your life if you go there. But you can see it's just like there's the library. Looks like a spaceship. Price Center's over here. There's the student commons right there. And yeah, it's just, I don't know. Like the ocean's right there. The temperature's 70 degrees every day. Like, I don't know. Like if I could ever be lured away from teaching at Clovis Community College, which I don't think I can be, like I would probably want to work at UCSD, honestly. So, the campus is huge, yeah, and you get a good workout too. Like if you got like some class over there, like you gotta hoof it, right? Peterson Hall's over here, so I did have some classes there, and 10 minutes later I'd have a class over there, so you just book it, you know, like across campus, you know. But yeah, so you know, the reality of the situation is like when people ask what college is better, you know, it always comes down to which professors you get. You know what I mean? Like, you know, you could have a garbage college. This is Sun God here. You could have a garbage college that just they just hired some new professor, and the new professor's amazing, and you know, you learn a lot. Like, or you could be at like Harvard, and maybe Harvard hires some person who, you know, has a famous name but can't teach worth a damn. That happens, right? Where, I mean, okay, one of the downsides to UCSD is that there are disembodied legs walking around. Like, it's been known to happen, you know, just severed legs. Just right. So that was AP&M. That was where I spent most of my life at UCSD. That used to be the computer science building. Is ugly concrete building from the 60s. Faculty club. We once tied a beer bottle to the sun god's arms. That was fun. A friend of ours died, and he wanted to pull that practical joke, and then he died in a motorcycle accident. It's very tragic. And so we got together, and in his honor, we pulled off this prank that he wanted to do for graduation. He graduated, worked as a professional software engineer for about 6 months, and then died. You know, and so there's a scholarship named after him now. So yeah, one of our guys is a rock climber, so he scaled the statue here, and we tied a giant inflatable beer bottle to the sun god. Allegedly. Sun god's over here too, apparently. It's looking down at you from the clouds. Yeah. Anyway, so yeah, it really always just boils down to the professors you get, and professors, especially in computer science, professors come and go all the time. So it's kind of like, you know, it really just depends on who you get and who your professors are. And so if you really want to get into it, look at what classes you're going to take, pull up Rate My Professor for every single one of those professors, and that'll give you a perspective on what your life's going to be like for the next 3 or 4 years, right? If people are saying this guy's horrible, and it's a mandatory class, it's like, yeah, guess what? You're going to go through it too, you know? So, the House of Blue Pants. It's funny. Okay. So, yeah, that's my talk on colleges. And honestly, for me, like, I suspect the actual education you get are going to be pretty similar no matter where you go. Like, I've seen homework assignments from Santa Cruz and Berkeley, and I've got issues with them, but why would you make somebody take this class in C? Like this class in C is just miserable. Do data structures in C is miserable because the C language is not well designed for data structures. Like, there's no member functions. Everything's a global function. Can you talk about the TC for a second? Yeah, go for it. But anyhow, yeah, the point is, I've seen assignments from around the UCs, and I don't know. Like I said, it just ultimately boils down to whichever professor you get. And so, if you want to get into it, look at the courses you will have to take over the next 2 to 3 years. Look at the professors for those courses. Look at the reviews, and then that'll tell you maybe which one you should go into. Because the professor is the most important thing, not the college. The college is just a name. Okay, go on, William.
Okay, so hi everybody. So we are near the end of the semester, and you guys are all pretty. I know there's a lot of you that are definitely either have determined that they don't want to be in computer science or that they do by now. And if you do, or if you find that you did really well in this class, I would definitely recommend applying to become a tutor next semester. And we're kind of desperate that at least a few of you do, because at least both Shami and I are going to be transferring next semester. So that's going to be 2 of really big Seaside tutors that need to be replaced. So definitely, I'll send this link and I'll pin it. But there's all the information to become a tutor if you click that link. We definitely really need people who know Seaside 41. It's probably the most requested class. So please apply if that's something you're interested in. And that's it.
Cool.
It's very fun being a tutor, by the way. I love it. Definitely.
Yeah.
Definitely been a good 2 years.
Yeah. Well, I mean, we can always hope that Muya doesn't get into any colleges.
Too late. I'm already in Irvine.
Darn.
And Davis.
But we do have, if you do go to Fresno State, we do have Fresno State people that are working in the tutorial center, right, Muya? Like Valenzuela?
Yeah, you can. Yeah, I think Valenzuela. Yeah, you can work. Yeah, if you're at Fresno State, you can still go. The only requirement for working at the TC is that you have 6 units enrolled anywhere, just in any college. As long as you have 6 units enrolled, you can. It's just to say that you are a student and not like a professional. Then yes, then you can do it.
Yeah. So so Emma, if you're gonna go to Fresno State, you can apply to be a tutor at the TC. One of the ways that I got good at computer science actually was by tutoring. When I was a sophomore, I became an undergraduate TA, basically what Muya is. And the titles are always different. I think my title was Proctor, which sounds kind of, I don't know, weird to me for some reason. I'm a proctor. Am I proctoring an exam? Am I a proctologist? No. I'm just an undergraduate TA. I don't know. But there's different weird titles for them. And the point is, though, in order to get good at something, you need to keep redoing it in your head over and over again. And so I didn't feel like I really understood. I passed 40 and 41 with A's, cool. Good job, me. But then it was when I TA'd it the next year and had to explain it to people and read their code and look at bad code and fix bad code and keep doing it over and over in my head that I'm like, I really get it now. And it really made a huge difference in my ability to program, and especially my ability to debug. Okay. Debugging, when I started off, it would take me 8 hours to find some logic bug, right? I would just sit there and try different things, and that would often make it worse, right? Because I would try something, I'm doing some for loop over a linked list, and I'm like, it's seg faulting, maybe I'll just do one less, and not go to the end. But then I was supposed to be deleting everything, but I wasn't because I was going one less, and now I'm leaking memory all over the place. And I'm like, why? And then I'll just try something different, and it just is, and it was horrible. And so being able to very quickly find where you make a mistake and very quickly fix it so that it's correct is one of the God tier skills you want to have. Like it's not just like A tier or S tier. If you can locate a mistake that you made and fix it like that, you go from wasting 8 hours of your life and being frustrated and hating computer science, like, oh, dumb mistake, fix it, move on, test, all test cases passed, let's do this, And so you can get some experience doing that just by writing homework assignments like this, because you'll make mistakes and you have to debug them and stuff like that. But when you're a tutor, you're going to see a lot of bad code, right? Like especially in CSI 40, like people don't really know what's going on. They're just trying different things, and the compiler's like, "Nah, I don't like when you try different things. There's a format for a for loop. You put in one semicolon, there needs to be two, and they don't know what it means, and so you get exposed to a lot of bad code, and so you just get practice over and over again identifying where a mistake is, zooming in on it, fixing it, testing it, didn't quite fix, test it, fix it, test it, and then done, right? It's like a master class in debugging, and you're not probably going to take a class in debugging, Like you do debugging. In this class, you do debugging, and in 45, you have to debug assembly, which is even more annoying. But like, you never get like that hands-on experience debugging. So, being a tutor, like if you're serious about computer science, I'd very, very highly encourage you to become a tutor. It will take you to like the next level of competency, and you get paid for it, which is nice. It's not like a lot of money, but like it's nice to have money. Like I've had no money before, and I've had money, and let me tell you, it's nicer to have money. Like when you can eat, it's a good feeling. Okay. Conscience does make cowards of us all. It's from Hamlet's soliloquy. Waitlisted in Berkeley, #1 college in the country for CSI. Yeah, I guess. Stanford's also #1. MIT is also #1. At a certain point, it's like Carnegie Mellon's also #1. It's like, at a certain point, like, #1 sort of loses its meaning when everybody's #1. It's like a participation trophy. Still call it #1, sure. Yeah. Carnegie Mellon, MIT, Stanford, Berkeley. UIUC, I've worked with them before, and I would say they deserve the reputation. Cornell, I've worked with. One of my friends is a professor at Cornell now. We're in grad school together. University of Washington, yeah. I'm friends with a couple of professors there. Yeah. I like them too. Georgia Tech. Georgia Tech has an online master's program, and as long as I guess we're talking about college stuff, because kind of that's it for lecture today. Unless you want me to go over Huffman coding again, that's basically it. What's his name? Why am I blanking on it? Matt Hodge at CART, I think just got his master's degree from Georgia Tech Online, if I'm remembering correctly, which I might not be. Georgia Tech has one of the top tier reputations in the South. So, on the topic of grad school, though, I highly recommend everybody go to grad school in computer science. If you're a computer science major, if you're just taking this class to like learn to program and then you're gonna dip out and do math or physics or something, okay, you don't have to. But like if you guys are computer science majors, a master's degree, I would say. I would recommend to like 90% of you guys. Grad school is a different experience from undergraduate. the hash table assignment that you guys did is a typical grad school thing, right? Where, I mean, not that particular one. That particular one is a typical junior level assignment where you benchmark hash tables and maybe do double hashing and quadratic hashing, benchmark and write report and stuff like that. The programming side of it was like a junior level, but that notion of like benchmarking and doing science, like it's actually science, it's computer science, studying what algorithms are faster and when, under what circumstances, and what operations and on what hardware. That's an interesting question, and that's what you do a lot of in grad school. Some grad school is just undergraduate but higher level, but a lot of it is actual science, which is cool. And then a lot of it is just reading papers. And so you will sit around a table with your professor, and they will hand out a paper, and you got a week to read it. You come back a week later, you sit around the table, you discuss the paper. And he takes notes, and assuming you read them and can offer constructive, criticism of the paper and show that you understand it, you get an A. In grad school and those kinds of classes, if you don't get an A, like you done goofed bad. Like it's actually kind of hard to get a B. Like a B is kind of like a D. If you get a B in one of those classes, like you like didn't do something. Like you have to do a presentation on week 7 and you don't do it. That's like D level work. Yeah, like it's like most of grad school, I'd say, is actually easier. I mean, assuming you can motivate to read a paper and take notes on it and stuff like that, it's not hard. Most papers are pretty easy to follow. And if they're not, then you read the abstract, you read the conclusion. that's most of what you need to know. Abstract, conclusion, look at the graphs, done. So, yeah, and then by the time you finish your bachelor's degree, you'll have kind of a basic level of understanding, and then when you go into grad school, you kind of take all the basic classes again, but at a deeper level of understanding. So even if you're just going to become a professional programmer and never do research or anything, having a master's degree is really useful, because like you take data structures now, right, in CSI 41. You take it again as a junior, and then you take it again in grad school. And so it's like beginning level, intermediate level, advanced level. And it helps. Like I think you can see, hopefully, from this class how important data structures are and what a giant difference they make in like running time and ease of use of programming and stuff like that. So highly recommended. And if you do it right, you don't have to pay for it. So undergraduates are kind of like the cattle that get milked, and fed into the slaughter, Like basically, undergraduates are the money stream to keep the college running. The grad students are the people that actually run the college. They're the people that oftentimes teach the classes, but like TA the classes, and they do the grading and stuff like that. They do the grunt work. The professors hate grading usually, Like I have an auto grader, so I don't mind it. I hit a command, grade the homework. I do that because I hate grading, right, by hand. And so you get TAs to do it for you. And so the grad students are the people that keep the college going. So you go from being like a cow to like a cowboy, or a cowgirl, right? And the owner of the ranch now knows your name and stuff like that. And it's a different experience. And they pay you, right? If you TA a class, you typically don't pay tuition, right? The TC here, they pay you 10 or 15 bucks an hour, something like that. If you're a TA in grad school and you TA a class like what Moy is doing, you get your tuition waived, right? It depends on the college, right? But, $15,000 a year that you don't have to pay, that's nice. Teaching helps you learn, that's nice. And you get paid, 20 bucks an hour, something like that on top of it. So I had enough money from TAing to have my own apartment with a roommate, and had a car and didn't have to pay tuition. And so I was kind of like, why graduate? Like I'm enjoying this. Like it was fun TAing. I enjoyed teaching, as I don't know, you might be able to tell. And I was getting paid to take classes and teach, and I was like, this is incredible. So my 1 year, I could have gotten my master's in 1 year, and I think I stood around for like 3 years because I took every class like I could basically, and I was just enjoying it, learning and teaching. It was free, negative free, negative expense. So, yeah, highly recommend you guys all go to grad school. Okay, so Princeton is Princeton, UT Austin, Caltech. Caltech's 11. Michigan's a huge school. They're one of the top schools, and it's a giant university too. Columbia, of course. UCLA is there. Harvard, UCSD. Boom, there we are. Right, so slightly behind UCLA. 4.0 versus 4.1. And I've worked with College Park, University of Northern Ireland before. Worked with them before. They were smart people. Rice, one of my advisors was from Rice. Very smart dude. USC, Yale, Brown, Duke, Johns Hopkins, and computer science. I didn't know that. That's interesting. I've worked with UNC Chapel Hill, right? I worked with them on high performance computing stuff. And then the Bridges people are UNC Charlotte. I don't know where they are in here. But UC Irvine, down 3.4. UC Davis, 3.3. Santa Barbara, 3.3. Yeah, but I mean, you have to take all these things, again, with a grain of sand. It's like, sure. Maybe they've got the best professors in the world, but can those professors teach? Right? So, like, Paul Eggert, the guy that wrote Shuff, he's a professor at UCLA, right? So, is he a good professor? Well, should I pull up Rate My Professors on a YouTube stream? Why not? Let's find out. So yeah, one of my students at Paul Eggert as at UCLA. Really? Oh, that's the school. All right. Schools, professors, Paul Eggert at UCLA. All right. So, yeah. Yeah. So, it's a pretty famous guy, in the computer science community, and you get to take a class with a pretty famous guy, So, yeah. I something being hard, honestly, it's not necessarily a bad thing, right? Like, especially if you're taking like a junior level class, you kind of want your professor to push you and stuff like that. So, I'm not really casting shade, but yeah, my student did say it was a hard class. Okay. Not a reason to not like a professor. Yeah. Okay. So that's basically my thing for today. So that's Java in a nutshell. Yeah. Java Rainfall, I guess, needs an auto grader. You might notice there's something called a.out in it. You might want to run this command here to make it executable, because the a.out is actually not an executable. a.out is a text file, and the text file contains the words Java Rainfall, right? So if you remember how Unix works, if you run a text file, if you set the execute bit on it, which is that, if you make a text file executable, then any Unix command you have in there gets run. And so, because you guys are used to typing a.out for stuff, when you type make and you build the thing, it compiles, right? And then you type a.out, that's wired into your fingers probably at this point. It's actually running a shell script. Technically, it's barely even a shell script. It's just 2 words in a text file. But in Unix, you can make a text file executable. And so when you execute that text file, it runs that command. And so it runs Java Rainfall for you. So sneaky way of sort of having an alias for running Java Rainfall. Yep. How hard 26 is? About the same as 41, I'd say. Yeah. So, I'll read through the Discord comments here. Wolf of Wall Street. You get this every day when you have money. Yeah, definitely after I started making money, I ate sushi a lot more. And probably good for your health overall. I don't know. Maybe not the cream cheese kind of stuff. Almost went to UW, but wife wanted to move here. Yeah. Working on the personal essay. Game design at CART. He was working on his master's. Yeah. I like Hodge a lot. Matt Hodge is a cool dude. I like him. Got waitlisted at Berkeley. Yep. Nice. Very cool. It's a lot different at different schools. Yeah, it's true. Like when I took discrete math, there was no programming. It was 2 quarters, by the way. It was 2 classes. And it was all math and all proofs. So I believe the woman that taught it was actually a professor in both the math and the computer science departments. And so the discrete math class really was math, and it really was doing proofs and proofs by induction, and there's no programming. And I don't personally like that, because what that means is you guys take 40, you take 41, then you go the summer without programming, you go fall during discrete math without programming, and then you take 45 assembly programming the next spring. So you've gone like almost a year without having written code. And then it's like, by the way, we're not doing C++ now, we're doing assembly, which is what C++ turns into. It's a much lower level of programming. No, it's like a train wreck. And so I do programming in discrete math, and I also think you learn it better, right? If you want to find the shortest path between 2 points on a map, write a program to do it, rather than just doing it mathematically. Write a program, and you understand it better, in my opinion. That's why I have you guys write these data structures in this class. It's because you understand it better after you write it. I thought you had to take 41 first to take 26. Yeah, it didn't used to be that way, and I changed it. And the reason why I changed it is because, like, if you want to do shortest paths, right? It's like the common way of doing it is with a heap. And if you haven't taken 41, you don't know what a heap is, right? So, good luck. Right? Like I think for the shortest paths, like I actually had 2 different versions. Like, I think I actually had 2 different versions of the thing. One for 40 people. Let's see. Yeah, for inventory, definitely. And so there's the one for people that have taken 41, and then I made a version for people that had never taken 41 and didn't know anything more than vectors, right? And so, you have to like just using vectors for everything, right? No classes, right? No classes, no fancy data structures, just vectors everywhere. And you can do it, and you can pass all the test cases. It's just far, far better to know data structures and to know how to do classes. It's really important to take this class. All right. So Bazookian is going to UCLA. Okay. What book is 26 using? We use iBooks. I do have one of the textbooks I've used before. Susan Epp book. It's pretty good. In fact, I think this was actually my textbook when I was in college. Susan Epp's been around for a while. It might just be a pseudonym by this point. So, the Epp book lives forever. And you can see it's got binary trees. I don't know if you can see that. Binary trees in there, and it's got solutions in the back, and tree algorithms and how many permutations and combinations of a set are there, how RSA encryption works, modular arithmetic, counting the sizes of sets, how you do proofs, trees. Yep. So your final Zybooks assignment will be on graphs, and that will be a lead into CSI 26. So you're not going to do any graph algorithms in this class, but in CSI 26 you do a lot of graphs. And what a graph is something like this. And so all a graph is, and it can really mean anything. You just have a bunch of vertices connected by edges. Okay? And so this could be like if you're trying to do shortest paths and you're trying to navigate from Seattle over to New York, there could be like each one of these edges could have a number attached to it that is like how far away it is. And then you can run shortest paths on a graph. Or this could be friends, you know, so person 1 might be one person 5 might be another person, and this line between them means they're friends on Facebook. And so, you know, this is like a social, if you've heard of the social graph, it's really, you know, a graph of all of the people on Facebook, let's say, and who they're friends with. Right? This giant billion node graph. So there are no labs for 26. There's no labs for 45. Yeah, something I've been requesting is that they add programming assignments, especially to Zybooks for 41. So I think it'd be helpful if students could do little programs inside of Zybooks on this. The hardest class in CSI is probably this one. I'd say it's probably this class. At least if you look at like the DNF rate, the percentage of students that get a D, don't finish, or an F. Yeah. With Lawton, you have 6 labs. Mm-hmm. Yeah. Why do you recommend doing grad school right after undergrad? Because once you start making money, it's real hard. It was nice going from undergraduate to grad school because I went from having to, you know, pay tuition in theory to having tuition free and getting paid to go to college. You know, you get paid to be a TA, or even better, you'd be an RA. An RA is a research assistant, so you don't even have to teach class. You just work for a professor, and you get your tuition waived, and you get paid, and you get to work on research, and usually that research turns into a paper, so you get published, or it could turn into your master's thesis, or it could turn into a dissertation, depending on the work you do. And so it was really nice. However, if I had gone from undergraduate into the real world and started making $100,000 a year, it's real tough to go back from making $100,000 a year to making 20. You know, that's pretty. Yeah, you get used to eating sushi. You know what I mean? And so, you know, if you don't know any better, it's fine. But you know, once you're making 6 digits, it's real tough to take a couple years off, you know. So best to just get it done. And a lot of schools have what are called a 5-year masters. So you sign up when you're around a junior or a senior, something like that, and you say, hey, I'd like to do the 5-year masters, and it's not even like a big deal. Like you just continue on for 1 more year and you get a master's degree. And to get a master's degree, you either have to write a thesis, which is what I did. It's a 20-page paper. Or mine was 100, but it's supposed to be 20 pages. I started and I just kind of kept going. I don't know. Or you can take a test. And so basically you spend 1 more year in college, you pass the tests, they give you they're called comps, the comprehensive exams, and you pass the test showing that you understand algorithms and data structures and operating systems, I think, are the 3. they're required for a doctorate. There's 5. There's also theory and something else. So for doctorate students, you have to pass 5 comps. For masters, you have to pass 3, and you can retake them. So it's not a big deal. It's like it's like the master exams we're doing here. Okay. And if you guys want to get more practice doing programming stuff, I do teach game development, like Muya is talking about on Discord. I do teach game development, and Muya, you want to show off like your triangulation code or something?
Yeah, I guess. Sure. Do you want me to pull it up, or?
I guess I can just become you.
Yeah, do the.
Yeah, you guys should have access to the ENC files. For those of you that are asking about that. Yeah, it's all world readable.
Also, the input tests don't make sense because they're technically testing if your ENC files are correct.
Are they?
Yeah, well, because it just looks at what the compression ratio was. Like, that's all the input tester actually looks at.
Right.
But it's testing the compression ratio on the public ENC files. So it's just going to test it on your code. Because it uses the same URL that was passed in at the beginning, which would have been the public link.
I see. All right, I'll have to look at that. Okay.
So you can technically do the entire assignment with just 4 lines of code by just doing the compression ratio, and that's it.
Yeah. I'll poke around to that. Okay.
But yeah, it would be in rasterization. No, rasterization. Yeah, rasterization.
So mouse support. Check this out. Putty. Click. Click. Oh, input a depth 5. Click. Input a depth 5. Click. Input a depth 10. Click. Input a depth 2. Click. Input a depth 2. Click. Input a depth 10. And so these 2 triangles, you see how they penetrate each other? So this has a depth of 2, this has a depth of 2, depth of 5, depth of 5, depth of 10. And so you can see, so in other words, the angle is like kind of tilted away from the viewer. And so they intersect each other. And I want to draw one on top. Let's see here, input a depth of 1, input a depth of 1, no? Okay. Click here, input a depth of 1. Click here, input a depth of 10. And so you see the triangle. They intersect each other, stuff like that. So kind of cool. Give Muya some clap emojis for that. I think it's pretty neat. So we're learning about the rasterization, like how do you put triangles on the screen, and do Z buffering and stuff like that. So oh, I see. You don't have access to writing it. Yeah. Yeah. I'll fix the test. I'll fix the test cases. Yeah, I'll fix the test cases. What about doing grad school part-time? Viable option? You can. One of my friends in grad school, he was paid by his work to go to grad school. So he would take 1 or 2 classes a quarter, and it took him X number of years to finish, like 3 or 4 years to finish. You can do it, I guess. I wouldn't. I would personally just bite the bullet, take an extra year, do a 5-year bachelor master's, and yeah, in part, I mean, sure, you're going to get paid more if you have a master's degree, but also, like I said, getting like grad school was actually just a good experience. Like, it was different from the undergraduate experience, and B, you learn everything deeper, and you become actually a much better programmer by getting a master's degree. A doctorate is useful if you want to do research. If you want to become a professor, yeah, go for a doctorate. If there's a specific line of research you want to do, sure, get a doctorate. I don't know. Most companies, when they're hiring, they don't care about doctorates. A master's looks good. A doctorate's kind of overkill, I guess. I was at a bar in San Diego talking to a recruiter, and he was like, "Yeah, I don't actually hire PhDs. I don't recruit PhDs because they're really really knowledgeable in one area and they're useless outside of it." Master's students, they're generally pretty competent at everything. But he's like, PhD students, like unless like I need somebody who's like an expert in this one particular field, I don't hire them. Like I actively avoid hiring them because they can't code. And I think that's probably a bit unfair, but yeah, that was his take on it. Anyway, can you go over the encoding function for Huffman? Sure. A minor for computer engineering. Yeah, minors in math are pretty common.
I'd probably say if you're in computer engineering, do physics. If you're in computer science, do math.
Yeah.
I feel like physics is going to be really useful in the long run for you.
I guess, yeah. I mean, you pick up most of the physics I think you need along the way, maybe. But yeah, physics minor could be good. I mean, you're going to have to take physics anyway, right? Like, you have to take, like...
Yeah, that's fair.
Like, as a computer science person, I took 5/4 of college physics, right? So, and that's on top of the AP physics I took. So, I think it works out to 8 classes of physics I took. And I'm a software guy, you know. All right, so write out the dictionary here, write out the encoded file here. Okay, so to answer your question, Emma, so let's say that you've got your Huffman coding done, your dictionary is done, and you're ready to write the encoded file. So let's say that you're trying to output, let's say the file just has ABC, right? And A encodes to 100, B encodes to 101, and C encodes to 111. Okay? So what you're going to do is say basically for every character in the file, you know, or the input vector, whatever it's called, you're going to have somewhere you're going to have a vector with every character in it, right? The original file. And if not, you can always just open the file up again and read one character at a time. Yeah. So for all of those, we're just going to go outs, and then you're going to have some data structure that holds the encoding, right? And so maybe it's a map, maybe it's you just got a vector that's indexed by the character ASCII code, something like that. So it'd maybe be something like, you know, if you have a vector called encoded, like that, or something like that. And so like, let's say you had a map that holds this mapping between character and encoding, you just do that, and then that would, sorry, no inline. Force a habit on the fingers, right? And then make sure you close the file also to flush it to disk. That's it. So basically, for every character in the input file, you're going to output whatever the string is, the 0s and 1s strings, and you're going to write that to this class here, this class I made for you. And so you just pass it a string of 0s and 1s, and those are actually going to turn into actual 0s and 1s, not a string. It doesn't write a string of 0s and 1s. The binary writer will actually bitpack successfully and write 0s and 1s to disk. Oh, generating the encoding strings, like how do you do that? Sure. So like, let's just not save this. Yeah, so this function here, which I call encode in the hints.cc, what it is, it's a recursive function that it works like this. So you start off by passing in root or something, and if you've got like an array of all the nodes or whatever, and the current string. And so basically, it's going to be a tree traversal, Emma. And so when we go to the left, we recursively call current points to left, and we append a 0 to the string, right? And if we ever reach a leaf on it, whatever string that we've built up gets written into the data structure that is holding all the characters. So if you go left, 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 then the string will be 0, 0, 0. It'll look something like this. It'll be like if current points to left, then recursively call myself, passing in current points to left, passing in R, passing in whatever the current string is, plus 0. And do you see how that'll build? And I guess we can do the same for the right. That's the function, more or less. Except when you get to a leaf node, when current points to left is null and current points to right is null, that means we're at a leaf. Then whatever string is, like if we do you guys see how that works? Like it's actually quite clever, honestly. So we've got a tree, and it's going to recursively call to the left, recursively call to the left, call to the right, call to the right. Every time it recursively calls down, it appends one more letter to the string, and then when it rewinds up the stack, the thing shrinks back down. So it's going to, whenever you hit a leaf, the string string variable is going to be like if we've gone left, left, right, right. It'll be holding 0, 0, 1, 1, and then you just write it into the whatever data structure you have for the for keeping track of what encoding goes with which character. Just write it in there. Here it's an array, but you can make that a map if you want. A map seems reasonable to me. So, am I walking the tree differently, or is your tree built differently? If you're getting a radically different compression ratio, that means your code is wrong. It's always possible you get like a rounding error or something like that. If it's off by like 0.1, that's one thing, but like you're talking about like 1.14 versus 0.3, right? Which is a little bit too much. So Watkins. Ooh, what is the desert? Yeah, okay. All right. Yeah, so your encoding algorithm is yeah, okay. Yeah, good. Yeah, that's exactly right. Okay. So what you're going to want to do is you're going to want to look at the .enc file, and look at the .dict file, and see if you can figure out, because the bits actually don't matter whether it's 0 or 1, it doesn't matter. But if the length are different, then it's wrong. Okay, so look at in the public directory, look at like test.dict versus your test.dict. So let's see, run it, test. Okay, and so let's cat test.dict. Okay. And if we cat public test.dict, public Huffman test.dict, you can see that my new line has 4 characters to it. The space is 1, 0 instead of 0, 1. That's fine. My A is 0 instead of 2. Okay. B is 3 instead of 2. C is 4 instead of 3. So that means that somewhere in your code you're not doing the Huffman coding correctly. Okay. The lengths should be the same. You might get a 1 and the 1s and 0s might be backwards, just depending on which way you pop it off. But the lengths should be the same as mine, or it's wrong. Right? It's not doing Huffman coding correctly. Okay. So I guess I can put a couple more test cases up there, like really simple ones, and then that might allow us to. Well, ASCII too, I guess. I guess we got some examples of that. All right, so that's it for today, guys. I hope you guys learned a little bit about life, coding, grad school. I know I've talked about grad school before, but it is actually, I think, really important for you guys to think about that. And I know the UCs are coming in, so if you want my advice on which UC to go to, I'm more than willing to offer my very biased opinion on it. But like I said, it always just comes down to the professors, and professors come, professors leave, you know. The world is in a state of flux and chaos. So. All right. So that's it for today, guys. Peace out.